if I write this symbol down, the integral from a to b of f of x dx, what does that symbol mean to you? It means area. Okay. If f of x is greater than or equal to 0 and continuous, then this integral is area. That's exactly correct. So if we have some function, f of x is always positive or 0, here's a, here's b, then what that integral means that area bounded on top by the graph and on bottom by the axis. And that's what integrals mean. Integrals, when f of x is a positive function, mean area. What if f of x isn't a positive function? What? So what if f of x looks like this, and f of x is a negative function?
Wouldn't it still officially be area because it's still with the...
Okay, but you wouldn't get the area. What would you get? Not surface area. You would get negative area because it's below the axis.
Does that mean we have to change it so that it's the absolute value?
Absolutely. Good one, huh? So if we want the area, if we simply do this integral, the integral from a to b of f of x dx would give us negative area because it's below the axis. So it would give us the area of this shape, but it would give us a negative number. What if I wanted you to find the area? Then what would you have to do? Just do absolute value. Okay? Now, let me ask you a question. Since f of x is always a negative function, what's going to happen when I put absolute values on it? What does absolute value do to something that's negative? Makes it positive. So what I could write is I could write the area is the integral from a to b of negative f of x dx. And that symbol tends to confuse people. People tend to say, well, then it's negative, isn't it? And the answer is no, it's really positive. Why is it really positive even though I put a minus sign in front of it? Because in this case, f of x is already negative, so a negative and a negative makes a positive. Okay? So if f of x is a negative function, if we want to find the area, then we simply put a minus sign in front of it. Okay? What if f of x is sometimes positive and sometimes negative? Okay, so what you would want to do is you'd really want to split it into two problems, wouldn't you? You would need to find this area, and then you would need to find that one doing the same trick, wouldn't you? You'd need to make it absolute value to make it positive, and then you would add the two areas together. Okay? So that would look like this. We would have some point in between C where it hits the axis. We would need to find the area, we would need to do the integral from a to c of f of x dx, and that would give us that area, correct? And then how are we going to find the area for that part below the axis? We'll do plus the integral from c to b, negative again, because it's below the axis. To make it positive, we need to put another minus sign in front of it. Negative f of x dx. So if I want to find the area of that function, I actually have to do two separate integrals. And that happens sometimes. Sometimes you have to do more than one integral. All right. What if...
So for these, are we going to have to do a lot of mean value theorem, or are we going to see what we get from
No, C will not be given. You'll have to figure it out, but it won't come from the mean value theorem. It'll just come from setting the equation equal to 0 and solving. We'll do some examples here in a minute. Let me just show you the next possibility that we're going to have. What if I have some function here, f of x, and I have some other function down here, g of x, and I want, here's a, here's b, and I want to find the area in between the two functions. Yes?
May I make a guess?
You may make a guess.
Okay, so first, you take the area underneath f of x to the x-axis. You subtract from that the area from g of x.
Absolutely. That's exactly what you're going to do. What you're going to do to find the area is you're going to find the entire area under f of x. And then, I wish I had a third color. Do I have a red pen? Let me see if I have a red pen. How can I not have a red pen? I'll try a pencil. I got a pink pencil. That's nice. And then what you would do is you would subtract that area. So what's that going to look like in terms of integral symbols? I integrate the top one minus I integrate the bottom one. But in general, what we would do is one of our properties of integrals is if we're subtracting, we can combine them together and make it one integral. But the important point is we always have to take the top function minus the bottom function. What if you were to do it the other way? What if you did bottom minus top? You'd get a negative answer. You'd have the right answer, but it would have a negative number in front of it. That would be no good. You want the positive answer. All right, then it gets really crazy. And after this one, we'll start doing some examples. Oh, I got two more, I guess. What if f of x looks like this, and then g of x look like that, and we wanted to find, we'll call it the area bounded by the two functions.
Does that count that little piece in the middle too?
Yep, that's stuck in between the two functions. What would you have to do?
So combine the one about doing the absolute value and then the one we just did.
Correct. So what you would have to do from here until there, which function is on top? G of x. So for this area here, you would have to do the integral, let's call this a and this c, the integral from a to c of top minus bottom. But then what happens between this point C and that point B? F of x is on top, so you'd have to switch it, wouldn't you? So you'd have to do a second integral that goes from C to B of f of x minus g of x. And so these are the sorts of things we're going to do in this section. We're going to be finding areas. And we're going to have all sorts of different situations. And what you really need to do is you really need to draw a graph and look at the situation so that you can know which function is on top, which function is on bottom. And you will always go top minus bottom.
For either of those, do you ever have to put a negative in every function?
No, because this minus sign takes care of the fact that this one is negative. So you'd have g minus a negative f is going to make it positive, and you'll get the positive area. So the only time you got to worry about a negative is if you only have one function and the whole thing is down below the axis. Then you do a minus. Questions on any of those? All right, here's the last weird situation, I think, that we'll get to. I don't know if we'll get to that today. What if I had something that looked like this? That is true. That is not a function. But I can still talk about this area, can't I?
Talk about it in the context of two functions.
Correct. This sideways parabola, I would really need to think of in terms of two functions. I would need to think of it in terms of the top half of the parabola being one function, and the bottom half of the parabola being a second function.
You find the vertex.
Well, I would need to know the vertex, that's true.
So you have to split it up.
How would I have to split it up?
You have to split up from the x-axis, since that's your vertex. You have to split and have f of x, like it'd be that portion of f of x and that portion of g of x, and then the negative portion of f of x and then the other portion of g of x. Or
Well,
you can consider a function.
yes, that would work. Or, the other thing I could do is I could split right here. And think of having this piece over to the right and this piece over to the left.
You have a triangle in the x right
Well, I don't know, since this is a parabola, I don't have a triangle. I wish that was a triangle, that would make life a lot easier. But it's not. Okay, so what would I have to do? Well, let's say we call this top half of this parabola, let's give that a name. What do we want to call it? F of x. Okay, so the top half of this parabola is going to be f of x. So what would we call the bottom half of the parabola? Negative f of x, right? Because it's just the bottom half. That would be negative f of x. And how about the line? What do we want to call that? G of x. Okay, so to find this area over here, what would I have to do?
Well, I'd say you find it from that line to the end and then multiply what's like, find the integral as if it was just the top half and multiply by 2.
Excellent, that would work. What I was thinking of, again, let's call this C and let's call this B. We would do the integral from C to B. I tend to think of it as top minus bottom still, which turns out to be exactly what you said. What you said to do is just do the integral from C to B and double it.
But how do we know for sure that the vertex is on the x-axis? No. But if it isn't,
If it isn't, the same idea will work. You can still go the top function minus the bottom function. What you would not be able to do in that case is James's trick, which is to just do the top half and then double it, because then it wouldn't be symmetric anymore.
so they need to make sure that you're working with the vertex on the x-axis.
Or if we're not, we'll see how to handle it. Okay? So we got one piece here where we go top minus bottom, and then we need this piece over here. We also need to go top minus bottom. So what's the top on this part? And what's the bottom? Negative f of x. So we would also need the integral from a to b, a to c, I mean, of g of x minus negative f of x.
Does that really cover it all?
That covers it all. Yep. Because I went g of x minus negative f of x. That's going to give me all this area.
Because you cut off that part.
Because I cut it off right there. I stopped right there.
Yeah.
And then this integral would give me this area.
I thought we said we wanted to take the one on top minus the one on bottom, but isn't the one on bottom like directly related to what's on top as well?
Yeah, they're just opposites.
So then why doesn't that affect that?
Well, just in this case, it's mostly because everything's nice and symmetric, but that's normally not going to happen.
But in this case, we cut it off at the point where,
We cut it off where they cross, which is important.
yeah, because then when you're trying to find the area of the part to the left of C, you're only working with g of x and the bottom of x.
Correct. Over here, my area is only bounded by g of x and the bottom half of the parabola. The top half of the parabola has absolutely no effect on that piece right there.
So that ensures that for each part you're only working with two functions, yeah.
Correct.
Otherwise it would be very complicated. So we're not able to do it.
Well, you could do it. The only way you can do it is to split it into two problems. James.
I was more talking about how the back of the right side like that you can just take f of x and minus f of x. Wouldn't that just cancel each other out?
No, it's f of x minus negative f of x.
I didn't see the negative.
Yeah, that little negative sign is snuck in there. So it becomes f of x plus f of x.
Okay.
Okay?
All right.
Oh, that's better.
So those are the same thing, integral from
Correct. Because f of x minus negative f of x becomes f of x plus f of x,
Yeah.
which is 2 times f of x.
So how would that change at any point in time? Because technically it would always be 2f of x,
That's correct. It would be.
even if it's not.
Even if it's up above. Yep. It will work still. 2f of x will always work. All right. Now, do you remember when we built rectangles? When we found areas originally building rectangles? How did we always build our rectangles? We always built our rectangles vertically. If you want to find area, do you have to build your rectangles vertically? Could you build them horizontally?
Yeah, but that's just one more thing to learn.
All right, but look at what happens with this one. If I were to build rectangles horizontally, no matter where I build the rectangle, notice that the rectangle always goes from the line to the parabola. Where if I build vertically, sometimes we go from line to parabola, sometimes we go parabola to parabola. And that's why we really needed 2 integrals. If I build vertically, if I'm over here, a vertical rectangle would go line to parabola. But if I'm over here, a vertical rectangle would go parabola to parabola. So here's my first one, line to parabola. Here's my second one, parabola to parabola. If I build horizontally, I always go from parabola to line. Correct?
Then you're dealing with the y-axis.
But then I'm dealing with the y-axis. So I could have the integral of this parabola I can think of as a function of y. So I could say this is going to be, I don't know what to call it, h of y, which is the sideways parabola, minus j of y, which would be the equation for the line, but in terms of j. And then dy, what would dy stand for? With what? Not really. Not when you're dealing with integrals. What's the dy? It was the width of the rectangles. So this would be the height of each rectangle. This would be the width. And this symbol would mean build an infinite number of them and add them all up. So we're going to do that sometimes. Instead of always using f of x and g of x, sometimes we will see that it's easier to convert everything in terms of y's. And then you'll only need one integral.
That's when you have something that's not a function.
Generally, that will happen when you're dealing with something that's not a function. That's correct.
With a circle, could you do it either way?
Circle would work either way. Right. Yeah, yes.
What about with 3 functions?
What about with 3 functions? 2 wasn't complicated enough?
That is
Okay. We might have 3. If you had 3, for example,
I hope there's not more than 3, but I can see that being mean.
1, 2, 3. And we would want to find the area bounded by all 3. We would want this area.
And my issue is that we've been doing this whole top minus the bottom thing, but since there's 3, you don't have top bottom.
Okay, but you do. You just have to split it into different areas. Again, what you would have to do is split it right where these meet. And then I would have top minus bottom. And then over here I would have top minus bottom. The difference is my tops change.
that way,
And that's okay.
any number of lines.
You could do it with any number of functions. That's correct. You just have to look at the picture.
Usually when you get to 3, things start to become a method that you can use independently.
If you have 3 functions, typically you're absolutely going to need more than one integral. The more functions you have, the more integrals you're going to need, the more complicated it gets. That's all. In this class, we're typically only going to deal with 2.
Essentially, we're working with 3 functions up there.
Essentially, we're working with 3 functions up here when we do it in terms of x, because we have the top half of the parabola, the bottom half of the parabola, and the line. So essentially, we were working with 3 functions there also. I agree. Okay, so let's do some specific problems now. Now that we have the idea of how messy this could possibly get. All right, so I'm just going to steal some problems out of the book here. It's giving us y equals x squared plus 2. Oops, I copied it down. I'm sorry. I started copying half of one problem and half of another. y equals, let's go with x squared minus 1. Y equals x minus 3. And then it gives us negative 1, x equals 1. So it's giving us 4 equations. Remember I told you there's only going to be 2? I lied. There's 4. But only 2 of them are functions. Only 2 of them are functions, so it wasn't a big lie. This is your interval. That's correct. This means you're going to integrate from negative 1 to positive 1. That's really all that is. That's your interval. All right.
That's infinite anyway.
All right. Well, I think the thing to do is to grab your calculator and graph these functions. Because you need to graph them. You need to know which one's on top, which one's on bottom. So you always need a graph. So calculators are going to be very important here. Y equals x squared minus 1. Y equals x minus 3. Okay.
The area is 0.
What's that?
The area is 0.
No, the area is not 0.
But when we go based on our interval,
It's not infinity because they told us we're only going to use the x's between negative 1 and 1. So we're stopping right here and drawing a little vertical line. Oh, I drew on my calculator. And then we're going to go over here and we're going to draw a vertical line. So we're looking at this little area right in here. So that is a finite area, isn't it? It is stuck in between. All right. So our answer would be the area is. Now, if they had not given me negative 1 to 1, my answer would have been real easy. My answer would have been infinity. It's not bounded. It goes forever. So we're going to have the integral from negative 1 to 1. Which function's on top? X squared minus 1. So it's going to be x squared minus 1 minus x minus 3 dx. There's my answer.
Well, that was really hard.
Well, I'm not completely done yet.
If f of x and g of x turn out to be the same function, that would area is 0.
That would mean the area is 0. That will not happen. Not in this class
What
anyway.
if they turn out to be exact inverse?
Then you get an answer. That's okay if they're inverses.
What if they're parallel?
If they're parallel,
Two parallel lines.
two parallel lines, then again, they would have to tell you where to start and where to stop on the x's. Otherwise, your answer would be infinite. All right, so all we have to do now is evaluate this integral. This is the integral from negative 1 to 1 of x squared minus x plus 2. So I distributed that minus sign through. I combined my like terms, find my antiderivative, plug my numbers in. Antiderivative is 1/3 x cubed minus 1/2 x squared plus 2x. Got to plug in 1, plug in negative 1.
I said that because I was just thinking it would be really, really annoying if you're working with two problems that look completely different but turn out to be the same one when you simplify it.
True. That would be annoying.
Unless you use a calculator.
Yeah, using the calculator is easier. All right, so I plug in 1. When I plug in 1, I get 1/3 minus 1/2 plus 2. Minus. When I plug in negative 1, I get negative 1/3 minus 1/2 minus 2.
Is there a way to figure this out without graphing it visually?
Well, without the graph, how are you going to know which one's on top, which one's on bottom?
That's what I wanted to know.
You need the graphs. Absolutely. Graphing is not an optional here. You've got to have the graph so you can see which one's on top, which one's on bottom.
Wouldn't it be plus 1/2?
No, because when I plug negative 1 in, negative 1 squared is positive 1. All right, so that's, let's see, 1/3 minus a negative 1/3, that's 2/3. Negative 1 minus a negative 1/2, those cancel. 2 minus negative 2 is 4. So my answer is 4 2/3. Questions on that one? All right, let's grab another one out of the book here. How about y equals x minus 1 cubed and y equals x minus 1. Notice this time they didn't give me the bounds of integration. They didn't give me the negative 1 and the positive 1. What does that mean?
there's probably a negative cross.
They're going to cross somewhere, and we're going to have to figure out where they cross. It means we got to graph it. Well, we had to graph it anyway, right? All right, so we will graph it. Y equals x minus 1 cubed. Absolutely. X minus 1. We graph. All right, so there's what the graph looks like. My opinion on that would be, I better zoom in because I can't really tell which one's on top and which one's on bottom, can I? All right, so I'm going to zoom in a little bit. Zoom in. There's the one with the cube.
How do you do it to zoom in the right amount? When I press zoom in, it zooms in a tiny bit.
Truthfully, I just got lucky. I hit zoom in, and it happened to be the right amount that time. Sometimes it will, sometimes it won't. That one just worked out well. Double stringed. Yeah. All right. So it does kind of look like a double helix. I agree. What do we notice about this problem? Which function's on top? Both of them. That's the correct answer. From here to there, which function's on top? The curvy one, which is which one? The one with the cube. That's the curvy one. From here to there, which one's on top? The straight one. Okay? So what that tells me is sometimes the curvy one's on top, sometimes the curvy one's on bottom. That tells me I need two integrals because it switches which one's on top. Anytime it switches, which one's on top, you need two integrals. So I need to know, first off, I need to know where does it start with the cubic polynomial on top? X is 0. How do you know that's x equals 0? Excellent guess. What happens when you plug 0 in? What's 0 minus 1? What's negative 1 cubed? Negative 1. What's 0 minus 1? Negative 1. So when I plug 0 in, they definitely meet there. So that's one of the answers. Where does that stop with having the cubic one on top? Looks like 1. Again, I would check it. 1 minus 1 is 0. 1 minus 1 is 0. So I need one integral that goes from 0 to 1, and that one has to have the cubic polynomial on top and the line on bottom. Plus, then I need a second integral, but I need to have the line on top minus the cubic polynomial on bottom. But I still need to know where to stop. Where's that point right there? 2. So this one's going to go from 1 to 2. And again, 2 is the right number. 2 minus 1 is 1. 2 minus 1 is 1. What would you do if the numbers weren't so easy, like 0, 1, and 2? What if they crossed at 3/4? You have two choices. You could set them equal to each other and solve by hand. Option number 2, second calc, intersect and find where they cross. As long as you're using your calculator to graph them, my opinion is you might as well use your calculator to solve them. So if I have to find where they cross, I'm going to use my calculator. I think it's going to be quicker.
If it ends up being some strange fraction, it will show you a decimal that makes no sense.
Yeah, but most of them are going to be pretty nice numbers. I'm not going to have them cross at 13/17. I just won't make it work out that way. The arithmetic gets too complicated. If they're going to cross, it's going to be something like a half or negative a quarter. It'll be a decimal you recognize. Okay? I wouldn't make it happen at some ugly number. All right, well, now I got an important question for you. How do I find the antiderivative of x minus 1 cubed? I have two choices. Number 1 is use substitution. Number 2 is to take x minus 1 times x minus 1 times x minus 1 and FOIL it out. Those are my two choices. You have to decide which one you like better. Which one do you like better? Use substitution? That's too bad because I know a formula for x minus 1 cubed. I could just write it down. All right, we'll do use substitution. U equals x minus 1. Well, that works out pretty nice because du is just dx.
Can't you just
That's what I wanted to know. I read the formula and I was interested.
If you multiply x minus 1 times x minus 1 squared, you will get it.
Oh, there's a formula for cubes too. I'll tell you the formula for cubes in a minute. All right, so this is going to be x minus 1 is u, so that's u cubed. X minus 1 is still u, isn't it? So that's just u cubed minus u du. And then what do our numbers have to be? If I plug 1 in, I get negative 1. And when I plug 1 in, I get 0. The second integral also has an x minus 1 cubed in it. So I might as well do a u substitution for that one too, right? And u would be? Same thing. So this one would become plus the integral. This one would just switch. It would be u minus u cubed du. Except what are my numbers going to be now? 0, because when I plug 1 in, 1 minus 1 is 0. And on top is 1, because 2 minus 1 is 1.
So the integral number basis went down 1. Like the top b and a from each integral went down 1.
Correct. So really all we did in this case is we did a shift of the whole integral. All we really did is we took this picture and we slid it 1 unit to the left. But by sliding the whole picture 1 unit to the left, does it change the area? No. It's really the same picture. It just slid 1 unit to the left. All right, I'm going to stop there for this problem. You can find those antiderivatives and you can plug those numbers in, right? It just takes a little time. James.
Is that what all of them do? Do they all center it back?
Yes. That's what u substitution is doing, is it's sending it back to the origin.
And that all makes sense now.
Okay. Now, here was the other option. If you have a plus b cubed, the formula is a cubed plus 3a squared b plus 3ab squared plus b cubed.
This is the triangle thing, because then you can do this for
It comes from Pascal's triangle, that's correct. If this happens to be a minus here, then you get a minus there and a minus there. So if I were doing this one on my own, I probably would have said x minus 1 cubed is x cubed minus 3x squared plus 3x plus 1, or minus 1. That's how I probably would have done it, because I happen to know that formula and could use it very quickly. I don't know. I almost think the u substitution is easier because I only got 2 things to deal with. Here I'd have 4 things to deal with. The u substitution was not a bad idea there. All right, how about this one? Y equals x squared minus 4x plus 3. And y equals negative x squared plus 2x plus 3. Again, they did not give me any bounds of integration. They didn't tell me x equals 0, x equals 5, or something like that. That tells me that these two graphs are going to cross, and I'm going to have to find those points. Most of that work is going to be done on my calculator. Y equals x squared minus 4x plus 3 negative x squared plus 2x plus 3 graph. Oops, gotta go change my window back, I think. Zoom 6. Alright, so I have 2 parabolas. And I can see that they definitely meet. So I'm looking at this little area in the middle here. How many integrals do I need? 1, 2, 3, 4? I think I only need 1 this time. Why do I only need 1 this time?
It doesn't switch from.
Does the top and the bottom switch? No. The top always has this parabola in the region that we're looking for. This parabola is always on top, and this parabola is always on bottom. So we only need 1 integral. That's nice. I like it when I only need 1 integral. So I need the integral. Which parabola is on top? The negative one. How do you know it's the negative one that's on top? Because the negative one, the one with the negative in front, is the one that's a parabola going down. All right, so we're going to have negative x squared plus 2x plus 3 minus x squared minus 4x plus 3. Probably the single biggest mistake people make on this, they don't put the second function in parentheses. You've got to put it in parentheses and distribute that minus sign through. dx. Now I need my numbers. Where do I start? Second calc. Intersect. It tells me one of the intersections is 0, 0. So that's this one. I'm going to have a 0 on bottom. For the other intersect, all I really need to do is move over close to that one over there and hit enter 3 times. And it tells me the other one happens at x equals 3. So that's how easy it is to find your bounds of integration. Use your calculator. You could set these two equations equal to each other. You end up with a quadratic equation, solve it by factoring or using the quadratic formula or whatever method you like. As long as you got the picture on your calculator, use your calculator. It's a lot quicker, a lot easier. More likely to be correct, too, which is nice.
That's
I make mistakes solving quadratic equations, too. It happens. All right, so again, I'm not going to work this one all the way out. This will be the integral from 0 to 3 of minus 2x squared plus 6x dx. And again, I'm going to stop there. Very simple, one polynomial. Find the antiderivative, plug the numbers in, see what you get. Questions on that? All right. How about, let's see, are there any good ones in here? Oh yeah, let's do our test. I forgot, thank you.